Hi. I don't know what it was like for you, but when I first started learning about test automation, I quickly got a little disappointed. After all, it was never quite as cool in reality as it sounded in theory. I had sort of imagined that the computer would do for me what I would otherwise do manually. Is that too much to ask? But no. Instead, test automation was an endless fiddling with tiny unit tests, or everything that was automatic happened without anything appearing on the screen, or in the worst case, it would be recordings. And then it was cool for like half an hour until something broke down, and suddenly you would spend as much time maintaining the tests as you did creating them from the beginning. Now, however, I work with really cool test automation. Let me describe a test case that I created for a customer who is working with logistics. They have a large and quite complex ERP system with integrations to a large and quite complex warehouse management system with additional routing systems, item management, a supplier portal, invoice management, and so on. In short, a whole lot of integrations. So an example of an end-to-end test at this customer site could be that the test robot first logs into the ERP system, which is on a web page, where it creates and processes a purchase order until it ends up in the supplier portal, which is also reached through a web page, where it does everything a supplier to my customer normally would do. The supplier receives a PDF confirmation, which the test saves a screenshot of. Then the ERP system is reopened to check that the correct status has been achieved. And in the background, a database check is done to see that everything has been entered correctly there. Then a desktop interface is open for the warehouse management system, where the robot acts as a foreman at the warehouse and does what he would do when the order is received. And then opens an interface that is used on the forklift tablets to store the purchased items. The last step is to verify the invoice, which is also found on a web page. The invoice is also a PDF file, but the content is a bit more important. So a screenshot is taken, but the text in the PDF is also read to verify the content. All of this can be viewed step by step on the screen. It is fully consistent with the daily work of people in the organization. And it would have required at least 3 people, and I don't know how much time to perform manually. And that is what I call cool test automation. And that is what the rest of this talk will be about. My name is Kristina Sabotic. I work with test automation and test leading at a Swedish consultant company named Adviceit. And what I appreciate most about working at Adviceit is that I have experienced and helpful colleagues to turn to, in combination with very good opportunities to learn new things. I am the kind of person who constantly need new challenges and chances to delve into things that I find interesting. Otherwise, I get tired of whatever I'm working on. Fortunately, there are plenty of challenges in test automation. Other short information about me is I live in Stockholm. I studied physics in Uppsala. I have 2 kids, and whenever I get some spare time, I spend that on knitting. The plan today is that I will first tell you my experiences of what it's like to test as an end user. And then it will be an introduction to robot framework. And lastly, a brief guide on how to get started with the first tests. And there will be time for questions at the end, but if something is completely incomprehensible, I'm perfectly okay with taking questions meanwhile as well. And I would just like to check with you, how many of you have used robot framework before? A few. Yeah. Then there will be some repetition for you here. How many have heard of it? A few more. Okay, great. So I work with creating end-to-end tests of business flows for clients who have complex structures of different third-party applications. This means that we generally do not work with access to the code, but work entirely as end users. Have you noticed that almost everything you read about tests in books and in blogs, and most of the lectures you hear and so on, is that testing is almost exclusively talked about in connection with development. But testing for an end user presents a completely different type of challenge. You must relate to several different systems from different suppliers that have different ways of quality assuring, documenting, and conveying information. From that, you need to piece together a functioning full picture, and as a tester, understand how the different parts of the organization work. A while back, I was at another conference with only robot framework users. And during a coffee break, I was talking to some people and complained about the troubles I had with a desktop interface where all the object IDs were dynamically set in a horribly annoying way. And the others, they laughed and said I had to go and talk to the developers so that I could get some sensible IDs to work with. Because they had never been in the seat not to work in direct contact with developers. But in my case, they are completely inaccessible because they are working at different companies. In fact, I think it's a lucky thing that I'm married to a developer. Otherwise, I might never meet one in real life. When we automate end-to-end testing for our customers, we aren't searching for errors in the different systems. The assumption must be that system testing is already done. So before starting to automate end-to-end tests, the customer's testing environment should be fairly stable. This is because of the test value. For an automated test to pay off, it must be something that can be run several times. And in a too unstable environment, especially where the actual processes aren't quite set yet, there's a high risk of writing tests that won't last long. And in a perfect world, the systems that you buy would already be of good quality when they are delivered to the customers. And that our challenge would just be to make them work together. But unfortunately, that isn't always the case. Therefore, it's crucial for an implementation or upgrade project to set up relevant quality gates where you check how the supplier has ensured quality in their product. This means that all suppliers must be able to answer a number of questions before we can receive any delivery from them. Questions such as how many tests have you run, how many errors did you find, how were the errors corrected, and how were the corrections tested. It seems kind of obvious, but it's amazing how different answers you get to such questions. And the worst answer in any case is, of course, I don't know. Of course, the important thing isn't to know exactly how many tests that has been done. Asking about number of tests is a little bit like asking how long a piece of string is. But what we're really asking is, well, do you have a piece of string? What do you do with your piece of string? And if they answer, yeah, of course, we have one. That is, if you can clearly explain how you've tested, it's a good indication that it's okay to proceed with the delivery. So, as I said, the goal of the end-to-end tests is not to test each product, but instead to verify the integration between the systems. And just to be clear about the concept, we're not talking about system testing of individual applications, nor about integration testing, where each integration is tested individually by triggering individual events to check that particular integration. In end-to-end tests, you build an entire flow according to how the business actually works. And the test run becomes a check that exactly that flow is working properly and that all integrations in the flow are intact. The test flows that we automate relieve the customer from what organizationally is quite complex testing, where people from different departments need to be called in to contribute with their knowledge of their particular part of the process. Usually there is no single individual who knows the entire process flow in detail, but everyone is an expert on their own part of it. And our customers don't generally have their own testing organization that oversees the entire solution. And those who are called in are not testers, but must pause their normal duties and devote themselves to testing instead. And that might be a fun change of scenery at first, but after a few repetitions, these flows become quite uniformly repetitive to run, which opens up for sloppiness and for misses. Because the tests are so burdensome for the business, it is difficult and expensive to test as often as needed. It's easy to realize that thorough tests need to be done when upgrading a large and central system. But what about all those other minor changes that are made? Upgrades in other third-party systems and patches and so on. You know, all those things that shouldn't affect anything. With the automated testing, it's just as easy to test a patch for a label printer as it is during an upgrade of a business system. So there's no need to skimp on test runs. And in addition to targeted test efforts, we also set up scheduled test runs every day to check that all integrations are in place before the workday starts. We create the end-to-end tests by identifying what the customer considers to be their most common and important process flows, and start scripting it as the happiest of happy paths, as straightforward as possible. Based on this, it's easy to develop variations with different deviations, which we identified based on what is usually complicated and what can pose problems. And in our projects, we have decided to almost exclusively test from the user interface because it becomes so pedagogical. It gives a larger part of the organization a chance to understand exactly what the test does, because it performs the same steps as a human would do. When something has gone wrong, you can follow step by step what has happened until the error occurred, which I will return to when we get to test reporting. So now it's time to look at the tool we use to create these test flows, or the actual test flow that I described in the beginning. Robot Framework is a test framework where you can combine a lot of different test tools to be able to test basically anything. It can be used for acceptance test-driven development, for end-to-end testing, and more recently also for process automation. It is easy to use to test against web interfaces, APIs, desktop interfaces, mobile apps, databases, XML files, PDFs, and so on. And all of these can be tested in the same test script. And Robot Framework is an open source project that is posted on GitHub with documentation, source code, task management of ideas and errors. The framework contains a bunch of built-in general test libraries and external libraries and tools that have been developed as separate projects. It does have an active community, so it's easy to get help, and it's easy to start contributing if you like that. The tests consist of user-defined keywords, and the test can be written so that they can be read as plain text, where you can follow step by step what is going on. Tests are organized as test suites in files, which in turn are sorted into folders. So with a little thought, it's therefore possible to get a really good overview when the amount of tests start to increase. The syntax of the test script is easy to read in plain text. There is no fussing about with semicolons and stuff. What could make the tests look a little bit more coded is if you use a lot of variables, because those are written in brackets, but variables shouldn't be seen in the test itself, but belongs in the keywords on which the test is based. And if you really want to, of course you can be messy and unclear even with the robot tests, but at least you have all the possibilities to be very clear. Tests can be set up in different ways, as either keyword-driven tests, test data-driven tests, or in Gherkin style. The keyword-driven tests can be written so that they can be read as plain text, where you follow step by step what is done. And each step here is a keyword that has its definition in a resource file or in a keyword library. The test data-driven tests can be used when you want to do many different variations of the same test flow. The actual test steps are summarized in a keyword that is used as a template, and the different test cases are created based on the test data you want to run and what combinations thereof. And these images are copy-pasted straight out of the Robot Framework user guide. And I want to take the opportunity to mention that this is quite a good guide, at least if you compare it to some other user guides that you can find. And lastly, it's also possible to write tests in behavior-driven Gherkin style, where the purpose of each step is described with given, when, and then. And one awesome thing here is that the same keyword can be used for all three types of tests. The keyword is shown in blue here, and those initiating words, given, when, and then, are ignored. It's not included in the keyword. So this means that the keyword that you see on the bottom line, welcome page should be open, it is exactly the same as the one used in the first example where we saw the same keyword. And if you want to, you could mix the different types of test cases in the same test file. That may not be so practical, but the point I want to make is that the three styles work in parallel. So you don't have to make any special adjustments to make one or the other. It is the user-defined keywords that makes it possible to create those easy-to-read tests. The test can be designed however you want them, and can be written so that anyone in the organization easily can read what the test contains. And again, this is truly important to us. That the tests that we create are accessible to other parts of the organization. It would be miserable if what we created were to be considered too complicated and incomprehensible, and we certainly gain more business if large parts of the organization of our customers can see the benefits of what we do. We usually start with one department, and then other departments sees what we've done there, and the word sort of spreads. So that gives us more business. As soon as a test contains several steps that will be executed in the same combination in several places, it is time to move them into a user-defined keyword. The keyword may consist of other user-defined keywords or keywords from a test library or a combination thereof. Usually, keywords are provided with one or more arguments, which makes the keyword reusable for different things. By making keywords that consist of other keywords, you can create several levels of keywords, which become more and more detailed the further down the structure you come. For example, the top level could be a general step like create purchase order. And the next level can contain the various steps required to create the order, and it's probably broken down based on where you do it. For example, if the order is first created on one page and then confirmed on another. The lowest level contains the keywords that are linked to a test tool and are defined in a test library. And the test libraries are usually written in Python. They could also be written in Java or .NET as well. It is the test libraries that provide all basic keywords, which all higher level keywords are based on. The framework has built-in standard libraries that handle things like dates, strings, dialogue, screenshots, etc. Then there are external libraries that in most cases provide keywords for being able to use some external testing tool, such as Selenium or Appium, or they can contain other functions such as a fake data generator and so on. Most such libraries are developed as separate projects based on the needs of the users. It is quite easy to create new libraries based on the needs of your own tests. It certainly helps if you know Python, but it's possible to get quite far with the most basic knowledge. I should know. And at my job, we occasionally have had other needs than has been available, and we have written our own libraries to cover the gaps. This means, for example, additions in how we handle different weirdnesses in web pages. In other words, our own addition to the Selenium library. And there is also a test tool for desktop application called WinApp Driver, which one of my colleagues has written a library for, and he has recently uploaded it to GitHub for other robot framework users to use and contribute to. A neat thing in Robot Framework is that it is easy to tag test cases by typing the tags as free text into the test cases. They can be used to define which tests to run by selecting or deselecting certain tags. You can also get statistics in the test report based on the tag. And when installing the framework, it comes with an executor, aptly named robot, which can be used to run the robot tests. The tests can be started from the command prompt by typing robot and the name of the robot file you want to run. And to make it easier to run the tests and to be able to schedule regular tests, we use Jenkins. So users who don't write tests themselves can use a web interface to put together their own test scope, enter their own test data, and start tests from there with just a few clicks. One of the very best things about Robot Framework is the reports. Each test run results in an output file in XML and 2 neat HTML files. One test log and one test report. And this is what a test report looks like when all the tests have in the suite has passed. And this is what it looks like when it has failed. Now, isn't that some clear reporting? Unless you're colorblind. But all the further information you might want is found in the test log, which looks like this. The test log has an hierarchical structure, which shows the test suites, test cases, and all the details of the keyword. Depending on what information you need, it's possible to open tabs down to the smallest part of the test. And when a test fails, the script can take a screenshot of what the situation looked like at that time. And in some scripts, we have built in a step that goes in and checks the status of the integration engine and takes a screenshot there as well. This means that whoever does the troubleshooting gets a clue if it's an environmental problem or a functional problem that the test has found. And the log also shows how long each step in the test has taken. A while back, I tested against a web interface for an application that was about to be upgraded. It was so slow it was impossible to work in any sensible way, which we reported to the supplier, who did some adjustment and then announced that, yeah, now it's resolved. The application is fast now. But for us, it was still slow, so the procedure was repeated. Slow for us, fast for them. In the end, it seemed like they hardly believed that we were just being cranky. So then it was very effective to be able to send the test log and show that, here, look, it took at least 42 seconds from the click until the page was displayed. And now, after your last adjustment, the time has actually increased to 46 seconds instead. And that got them working. It is easy to get started with Robot Framework. I've talked through all the steps, all the parts that is needed to know to run a first simple test. So now I will show you how to set it up, and you can do the same when you're back at the office on Friday. So Robot Framework requires an installation of Python. Once you have that, it is easy as pie to install Robot Framework. Simply type pip install Robot Framework in the command prompt, wait a few seconds, and it's done. And most test libraries also work with pip installer, so it's really super smooth. And a very first test case is written in 3 lines. The first line is a headline that marks the beginning of a section of test cases. And in larger test files, there are also sections made for settings, variables, keywords. And then we must have a name on the test case, which is in line 2. And on the third line, a test step. In the built-in library, which is fittingly called built-in, there is a keyword named pass execution, which will pass the test and return whatever argument we put in, which here is hello world. The keywords that are included in a test are always written indented, and there are 2 spaces between the keyword and its argument. Then the file is saved with the extension .robot, and to run the test, you first write the executor, robot, the name of the test, which here was given the imaginative name test.robot. The test passes, the output becomes the text hello world, and at the bottom there are the output files that I talked about. That's how easy it is. Now, we are not far from being able to run more interesting tests. For example, web tests with Selenium. For that, we must have a test library for Selenium, and it is installed the same way with pip install Robot Framework Selenium library. And you also need a WebDriver, which is the same WebDriver as if you run Selenium without using Robot Framework. So these are found on the Selenium website. And this WebDriver will open a browser, send commands to it, and receive the results exactly the same way that a user does. And you'll need a specific WebDriver for each browser you want to test against. And to run a test now, the script requires at least 2 sections. One for test cases and one settings section, where the script calls the Selenium library. Here's what a first test case would look like. It will open Chrome, go to today's conference page, and verify that the word Europe is there. I really want to encourage you all to try this. Give it a few minutes on Friday, because it will quickly become really fun. So it's time to sum up some things that I like most with Robot Framework. And the first thing is that it is possible to test almost anything, and that it's really easy to get started with a few steps, just to get a feel for how the tool works. And good-looking reports will appear from test 1. And last but not least, the community. I've become so hooked on this whole open source concept, which was all new to me just a couple of years ago. And in this case, it is an active and welcoming community that is quick to help out beginners and engaged and smart when you have more complicated problems. But any community would be a little bit better with you guys in it, wouldn't it? So that's obviously the magic of open source projects, that the users and the the more users and contributors there are, the better both the products and the user will be. So when you have tried this on Friday and you got hooked just like I did, just get in touch with me and we can have a chance to create some new awesome ideas. And now it's question time.